Hello everyone, welcome back. In this video, I want to talk about and review how to graph a line or a linear equation. And so I want to go ahead and jump right in with this example. And so we actually have 3 examples written on the board here, but all these examples are representing the same line. And so we're asked to graph the linear equation negative 2x plus y equals 1. We're going to see that this is exactly the same as graphing the linear equation y equals 2x plus 1 or the linear equation y minus 5 equals 2 times the quantity x minus 2. And so if we want to graph one of these linear equations, we have to find points that are going to be on the graph of that linear equation. The graph of a linear equation gives us a line, and in order to find a point on a line or a point that satisfies that linear equation, we have to find a pair of x and y values that satisfy or make these equations or statements true. Later on, we will talk about other strategies that we can use to graph lines using things like the slope of the line and a point that the line goes through. But for now, we're going to start with the most basic approach that we can use to graph any function, but we're just going to apply it to a line. And that's by creating a table of values, finding a bunch of points that the graph goes through, and then plotting those points and connecting them with a line. And so a table of values will help us generate a bunch of points on our line. So let's go ahead and start setting up our table of values. And so in the left-hand column of our table, we will put our x values, and in the right-hand column of our table, we will write the corresponding y values. And so now we're going to pick a value for x or y, plug that into one of our equations, and solve for the remaining variable. Some equations will be easier to work with and do this compared to others. What we're going to see is that all these equations are representing the same line, so it doesn't matter which one we use, we're going to get the same y value or x value depending on which one we start with. So let's go ahead and start by plugging an x value in, and I'm just making an arbitrary choice here. Let's go ahead and plug x equals negative 1 in. And so if we plug x equals negative 1 into our first equation, we're going to get negative 2 times negative 1 plus y is equal to 1. And now we can solve this for y pretty quickly. And by doing so, we'll find the y value that corresponds or goes along with this x value of negative 1. Well, negative 2 times negative 1 is positive 2. So we have positive 2 plus y is equal to negative 1. If we want to get y by itself, we're going to have to subtract 2 from each side. And that'll give us y is equal to negative 1. And so now we can go back to our table of values here, and we see that, well, when x is equal to negative 1, y also has to be equal to negative 1. So that gives us an ordered pair, an x value and a y value that we know has to be on the graph of our line. So we can now plot the point negative 1, and that'll represent 1 point on the line. Before we actually plot our point, though, let's just go ahead and look at our other equations and see that this point will also satisfy those equations and therefore be on the lines represented by these equations. But we're going to see that these lines are all the same, just represented slightly differently. Okay, so if we're going through the same process that we used for our first equation, what we want to do is plug negative 1 in for x. So we get 2 times negative 1 plus 1. And now if we evaluate that, we should find our y value. Well, 2 times negative 1 is negative 2. Negative 2 plus 1 is negative 1. So very quickly, we again find that y is equal to negative 1 when x is equal to negative 1 as well. Okay, let's go ahead and do this again for our third equation down here. Same starting point. We're going to try to find y by plugging in an x value that we randomly chose. Oh, not quite random. We don't want to pick x values that are hard to work with or plug in. So we'd like to stick with nice values that are integers, but sometimes it does make sense to plug fractions in. But we probably don't want to plug pi or the square root of 2 in to help us find an x or y value. Okay, so back to our example here. So we're plugging in x equals negative 1. And we're trying to find the corresponding y value. So now we have to solve this equation for y. Well, let's go ahead and do it in maybe a couple more steps because a lot's going on. We'll leave the left-hand side as y minus 5 for now. But on the right-hand side, inside of these parentheses, we have negative 1 minus 2. That'll evaluate to negative 3. So we have a factor of negative 3 that gets multiplied with a positive 2. That'll turn into a negative 6. So now our equation simplifies to y minus 5 is equal to negative 6. But if we add 5 to each side, we get y by itself. And we see that y is going to be equal to negative 6 plus 5. But that is negative 1. And so it doesn't matter which of the 3 equations we used here. When we started with that, chose an x value of negative 1 and plugged it in and found the corresponding y value. all three equations gave us that y is also equal to -1. So we need more than 1 point to graph a line. At minimum, you need 2 points to graph a line, but it's sometimes nice to have a third point just to use as like a checkpoint for our line. So let's go ahead and continue filling out our table. We'll do at least 1 or 2 more entries. All right, so our first entry in our table was we started with a chosen x value of -1, then I found that y must also be equal to -1. If we want to find another entry for our table of values, we can either choose a y value or an x value. Let's go ahead and pick another x value. That's what we typically do in these situations anyways. So let's just go ahead and see what happens when x is equal to 0. So we're going through our process again, but now starting with x equals 0, we're going to plug x equals 0 into our equations and then find the corresponding y value, and that'll give us a second point that we know our line must go through. So if we look at our first equation, it says -2 times x plus y is equal to 1. Well, now our x value is 0, so we get -2 times 0 plus y is equal to 1. This simplifies very nicely and very quickly. -2 times 0 is 0, so that just disappears, and the left-hand side is just y. So we get pretty quickly and right away that y is equal to +1. Now remember, I claimed earlier that all three of these equations are representing the same line, so if we plug x equals 0 into these second and third equations, we should also find that the corresponding y value is +1. Let's go ahead and try to verify that. So we're trying to find y when x is equal to 0. If we plug x equals 0 into our second equation, we get y is equal to 2 times 0 plus 1, but 2 times 0 is 0. So the right-hand side simplifies to just +1. So once again, we are seeing that when x is 0, y has to be equal to 1. Let's go ahead and finish this off with our third equation. So we're plugging in x equals 0 yet again. The left-hand side we're leaving as y minus 5 for now. But let's go ahead and try to simplify that right-hand side just a little bit. 0 minus 2 is -2. So inside of these parentheses, that simplifies to a factor of -2, which we have to multiply by +2. +2 times -2 will give us -4. So now our equation is looking like y minus 5 is equal to -4. To get y by itself, we've got to add 5 to each side. And there we see, yet again, that y is going to have to be equal to +1, this time through -4 plus 5. So now we can confidently fill out that y value in our table. We know a second point our line goes through is going to be the point 0, 1. And this point has a special name to it. If you remember some stuff about lines, that is what we refer to as the y-intercept. That is where our line is going to cross the y-axis. We'll talk more about that later though. Let's go ahead and find a third point on our line. We really only need 2 to graph our line. This third point will just be like a checkpoint. Okay, so far we've chosen x values of -1 and 0. If we're going to continue that trend, I think it makes sense for the next x value to be +1. So let's go ahead and clear up our workspace, and then we'll go ahead and plug x equals +1 in and try to solve for y. All right, so now let's go ahead and see what happens when we plug x equals +1 in. For our first equation, we'll get -2 times +1 plus y is equal to +1. So that first term is going to simplify to -2. If we want to move it out of the way and get y by itself, we have to add 2 to each side. And if we add 2 to each side, we do get y by itself, and we find that y has to be equal to +3. Let's go ahead and make sure our second and third equations agree with this and say the same thing. So let's go ahead and plug it into our second equation now. So what is y when x is equal to +1? Well, we plug x equals +1 in, and our second equation pretty quickly evaluates to tell us that y is going to be equal to 2 times 1 plus 1, or 2 plus 1, which is 3. But that shouldn't come as a surprise to us at this point. One more to go. Let's go ahead and finish it off. So in our third equation, we have y minus 5 is equal to 2 times now 1 minus 2. Well, 1 minus 2 is -1. So we have -1 times 2, or 2 times -1. That evaluates to -2. And now if we want to isolate y or solve for y, we have to add 5 to each side. In our third equation, we see that y is equal to -2 plus 5. But what do you know? That's +3. So We now know a third point that our line must go through. It's the ordered pair x comma y, where x is equal to 1 and y is equal to 3. And so now we know these 3 points, we can go ahead and graph our line. So let's go ahead and do that on these axes that I have prepared. Our first point is -1, -1. So remember, the x value tells us how far we move left or right. And then the y value tells us how far we move vertically up or down, with our starting point being 0, 0, or the origin. So -1, -1 tells us we have to move left 1 and then down 1 to get to our desired point on the line. That's going to be that green dot right there. Our second row in our table gives us another ordered pair or a set of coordinates that our line must go through. X has to be equal to 0 and y has to be equal to +1. So x equals 0 means we are on the y-axis. And where on the y-axis are we? Well, we're at that spot where y is equal to 1. Remember, this is what we refer to as the y-intercept of our line. And we really only need these 2 points to graph our line. A line is uniquely determined by 2 points. But we found this third point, so let's just go ahead and throw it up there. And our third point says if x is equal to 1, then y has to be equal to 3. So that'll put us right about there. And so now this is sometimes the hardest part for me. We now have to connect these 3 points using a straight line, or at least the straightest line that I am capable of drawing. And so there we go. In green, we have the graph of our line. This is the graph of -2x plus y equals 1. It's also the graph of y equals 2x plus 1, as well as the graph of y minus 5 equals 2 times the quantity x minus 2. So remember, to graph this line, we just generated a bunch of points that the line must go through. We did that by selectively choosing some x or y values, plugging the choice we made into our equation, finding the value for the other variable, and then those values together give us a point on our line. So out in the wild, we will not usually be working with 3 equivalent representations of a line at the exact same time. I really wanted to do that in this example, though, to illustrate that we can represent a line in different ways.